Hey everyone, welcome to the refresher workshop for the data science track, which focuses on Python. Our instructors for this workshop are from SMOC, which is the Student Machine Learning Coalition. Please say hi to Sanjana, Joseph, and Aswin. Sanjana, how you doing?
I'm doing great. Hi, everyone. My name is Sanjana. I'm a junior at Limburg High School, and I'll just be helping out with the implementation part of the presentation today.
All right, thank you so much. And then Joseph, how are you?
Great, thank you for asking. My name is Joseph Thomas. I'm a junior at Bellarmine College Prep, and I hope you learn a lot from this workshop today.
Great. And last but not least, Ashwin, how you doing?
Doing great. Thanks for asking. Hey everyone, my name is Aswin Surya, and I'm a sophomore at Bellarmine College Prep, and I'm going to give you guys a refresher on Python.
All right, well, let's go ahead and get started.
Can y'all see this? Or is this weird? Okay, there we go. All right, everyone, welcome to the Intro to Python. We'll be covering 5 different sections, starting off with variable and data types, next loops and conditionals, list accession, list comprehension, and finally finishing with functions in Lambda. So let's get started. So the first thing we'll be covering is variables and data types. There are four basic data types. The first is Booleans, which returns a truth value, either true or false. The second type is float, which returns a decimal number. So even a regular number with a decimal is a float, like 1.5 or 3.0. The third type is integers. These are simply regular numbers, no decimals, and can be positive or negative, like -1 or 1. And finally is the string data type. This is simply a line of text that is set off by single quotes or double quotes. So how do we convert from one data type to another? We use an input function to take an input from the user. Since it is default a string, you can use the float function or the int function to convert to a data type of your choice. You can also use the type function to check the data type of any variable. Now, that was a quick overview on variable types. But next, let's go to loops and conditional statements as for the actual logic of writing code. So the first type of loop is while loops. This type of loop uses a while condition and then does an action and then updates the condition. So until the condition is met, the action will keep repeating. Sometimes you can get stuck in an infinite while loop, and that's something you'll have to debug later on. The second type of loop is a for loop. The syntax for this is for a variable in a certain range where you increase the increment of that range, it does a repetitive action. The variable automatically updates to increase the count until it hits a certain threshold. For example, the range of x could cycle through the numbers from 0 to x minus 1. Finally is if-else statements. This is a pretty simple piece of logic. If something happens, then an action takes place. Else, if something else happens, another action takes place. Else, if neither of those things happens, a third type of action takes place. You can chain as many if-else statements as you want to form the logic of the project you're working on. Conditions can be equality, which is represented by 2 equal symbols, greater than, which is for some reason switched, it's the greater than symbol, and less than is the less than symbol. And there are many other conditions as well. All right, let's move to the third thing is lists, the basics and the accession of lists. So the basics of lists and tuples are that they're basically placeholders for holding values. A tuple is a set of 2 values enclosed by parentheses, while a list is a set of multiple values enclosed by brackets. Example, the string of numbers. Tuples and lists can be held by one variable. So the advantage is that you can represent a whole set of values based on simply with the one variable itself. So for lists, it's simply another type of variable or data. This is extremely important in basic Python because it holds multiple values with one variable. That's important for keeping track of inputs or creating rudimentary data sets. Other data types like arrays or series are based on this as well. Next, how do you access these terms in the list? That's where indexing comes in. The index is the position of a certain item in the list. The syntax for this is represented by brackets. So for example, if you wanted the first term in a list, that would be at index 0. It seems a little counterintuitive, but you eventually get the hang of it. If you want the second term in the list, that would be index 1. So remember that the index always starts from 0. This is also extremely important in data science where you want to access some term of a data set. Next, there's some other syntax. So this just clearly illustrates how you can even get a range. For example, if you want the colon represents anything after 0, so it would represent 0, 1, 2, 3, 4, 5. Additionally, the 2:4 represents 2 and 3 since that's after 2 and before 4. There's some basic list functions. You don't have to memorize all of these, but you can just know them for your reference. Count counts the amount of times an item shows up. Append adds an item to the end of a list. Remove removes an item. Pop removes an item at a specified index. And others include clear, extend, and reverse. Once again, you don't need to memorize any of these, but you can always refer back to this video in case you're using these in your project. Next, we'll move to list comprehension, which is a little bit more advanced usage of lists. So what is list comprehension? It's basically creating lists in only one line. The loops, equations, and conditions you need can be condensed into one line of code. This makes the code more organized and compact. In fact, list comprehension is extremely powerful and really efficient. So what's the basic syntax? The syntax is the list name equals the bracket of the expression for variable in the range, and then you specify the range. For examples, number equals the bracket of A for A in the range of 1, 6. That gets the numbers from 1 to 5. The list gets saved in the numbers variable. This diagram gives a simplified explanation of lists as well. There's some other examples too. Let's say you're using an if statement to find even numbers. Even numbers equals bracket I for I in range 1 to 10 if the remainder of I equals 0. For all even numbers, the remainder is 0, which means that this variable will represent all of the even numbers from 1 to 10. You could also use an if-else statement, even or odd. This statement shows which numbers would be even or odd using this list comprehension metric. Finally is functions and lambda. What are functions? Functions are blocks of code specified under one name like a variable that runs when you call the name. Functions are extremely useful in data science to segregate specific actions of what you're trying to do. The basic syntax of functions. You first define the name of a function, pass in any parameters which you might want to include, then you do the action, which is the actual code, and finally you return a value, but you don't necessarily have to. That's optional. When you call a function, you call it by its name and whatever arguments you have. That goes in the parameter section. Remember that a parameter is the variable name used inside the function, like using the letter X to denote the input, while an argument is the actual input that gets passed to the parameter, like using the input function and getting a number Y that you use. Let's give an example. Let's say you define a function sum, and it takes two parameters, A and B. Let's say it's a simple sum function. So the sum equals A plus B. Then it would return sum. So, but the arguments, let's say you'd call it sum of 1 and 2. The function A would equal 1 and B would equal 2. So this sum function would return 3. Now, this is a much more powerful way of writing functions called lambda functions. or lambda expressions. The lambda expression is an equation and a manipulation. So for example, this lambda function is represented by this lambda expression, and you put a colon and it's x plus 2. So it simply does a simple function by condensing it into one line. Lambda functions are a great way to condense functions. Thank you so much for listening to this review on Python, and Sanjana will do an implementation on these concepts.
Yep, thank you, Aswin. Okay, so let me share my screen. Okay, so we're gonna start off by going over loops and conditionals, which Ashwin went over really quickly. So let's think about conditionals first. So conditionals are basically statements which will give you a true or false Boolean value when they're executed. So let's say we have two variables, a is equal to 1 and b is equal to 2. If we run this, it should work. Okay, so if we say, let's say our conditional statement is a is greater than b. So obviously this is a false statement, so it should print out the false Boolean value. Yeah, okay. So we can do another conditional statement. Let's say print b is greater than 1. So this is true because 2 is greater than 1. So if we run that, it'll be true. Okay. So let's also go over quickly data types because we need to make sure we understand those. So let's say we have a value 3 to the power of 2. So if you remember, 3 to the power of 2 can be written like that. And let's say we want to check if that's equal to 9, but we're given an input of 9. So whenever you have an input function, the value, the data type of that value is a string. So if we say equal to string of 9, it would be false because again, the data types have to be the same. Okay, so we'll move on to loops. So we'll start off with while loops. So again, while loops have a condition and then they have an action, and then they update that condition so that the while loop doesn't go on forever. So we can assign x to 0, for example, and say while x is less than 10, let's print x, and then let's add 1 to x each time. So if we run this, so x starts off at 0, it prints out 0, and then each time it goes through the while loop, it'll add 1 to x, and it'll print that value in a new line. Okay, next example, we'll do for loops. So let's say we want to iterate through a range function, which we went over. So let's say for x in a range 1 through 10. So this basically means x will go through the range 1 through 10, 1 included and 10 not included. And then we can say print x, and then it should print out 1 through 9. Yeah. And then we can do, for loops can also go through lists. So you can think of like a range function as like a range of numbers or like a list of numbers. And you can also just put in a list for the for loop to iterate through. So you can say 1, 3, 5, 7, 9. And let's just say we want it to print out that number to the power of 2. So here, I'll see. Yeah, so it'll print out 1, 9, 25, 49, and 81. And these are all squares of the values inside of the list. And you can also go through strings. So when you iterate through a string in a for loop, it basically goes through each character in that string. So we can say, let's say we have a string Python that's in the variable x. So we can say for y and x, let's print y. So So this will print out each character inside of Python. Okay, so next we'll go over if-else statements. Okay, so let's say we have an input, and let's say we give the user a simple question. What is 1 plus 2? So we can put an if statement to check what the answer of the input is. So you say if answer is equal to 3. So this equal to is not assigning answer 3, but is instead checking the value of 3. So if we have the statement, the conditional statement answer is equal to 3, it will either return true or false. So we could say print, wow, you're really good at math. And then if it's not equal to 3, we just say else. And we would say print. I'm not that great. Okay. So when we run this, there will actually be an error. So let's figure out what that error is. So let's say, what is 1 plus 2? 3. You're not that great at math. So the answer is 3. We know that the answer is 3. 1 plus 2 is 3. But basically the reason why this if loop is not running correctly is because we have this input function again. And remember, whenever we have an input function, the data type of the input is a string. So we have to make sure that we're comparing the string or the integer to an integer, or a string to a string. So we can say if answer is equal to in quotes 3, which turns it into a string. Or you can also use the string function, string 3. And so if we run that, wow, you're really good at math. So that runs correctly. Okay. So there's also elif statements. So we have if-else statements, if-elif-else statements. So we'll go over an example of an if-elif-else statement. So let's say we have an integer 16, and we want to check if the integer is positive, negative, or 0. So we can say if x is less than 0, print less than 0. And then we can also say elif x is 0 and print and then for any other value, we would print your number is greater than 0. Because again, we have the condition met that if x is less than 0, it would be less than 0. If it's equal to 0, then the variable is 0. And so the only condition that we have left is that if x is greater than 0. So we can say greater. So if we run this, we should print out greater than 0, since 16 is greater than 0. We can also do negative numbers, negative 13, less than 0, and then 0. Yeah. Okay, let's move on to lists. We'll do some accession. So let's say we have a list called list1. And remember, when you're creating the variables, you don't want to use keywords like list, because that's a keyword. It won't assign it to a variable. So you want to make sure you don't use that. So we'll say list1 is equal to list of numbers 1, 2, 3, 4, 5, 6, 7, 8. And so let's say we want to get the number at the index 0. So we would say print list1. And so the index 0 right now is this number 1. And so index 1 would be number 2. So when we're using lists, we have to make sure that we put the index inside of the bracket. So that would be, for the value 1, it would be index 0. So it should print out 1, yeah. And then we can also get the value of the 5th index. And so that's 6. So remember, it starts off at 0 and then it increments by 1 for the index of the list. Okay, we can also go over list slicing. So list slicing is basically if you want a specific part inside of a list, you can write the list like this. You can access these values by saying list 1, and let's say we want to get the values 3 through 5. So 3, if we count, that's 0, 1, 2, that's the second index, and then 5 is 3, 4, that's the 4th index. So we would say 2 to 4. We print that out, that's 3, 4. Okay, so if you see what happened, basically, again, it starts off at the second index and then it goes 1, 2, and then it doesn't end at this last index. So this means that you have to stop at index 4, but you have to stop at the index before that. So it's going to give you 3, 4 instead of 3, 4, 5. So if we did 2, 5, then it give you 3, 4, 5. Okay, and then there's some other default values in list slicing. So if we say print list 1, we can say 4 and then colon. And then this will basically give you the values inside of the list from index 4 to the end of the list. Yeah. And the same goes for the value on the right side of the column. So we can say list 1, let's say we want to go until from the beginning to the 3rd index. So we won't include the 3rd index. So it'd be 1, 2, 3, which is index 0, 1, 2, and then it'll stop there. There's also the functions that we went over. So let's do another list. And I'll just copy paste it so it's easier. So we have a list of characters, A through J. And let's say we want to append a value to that list. We would say list1.append. And let's say we want to add 1. So that would basically add the value 1 to the list at the end of the list. And then we can print. So here you see at the end of the list, we have the value 1. And then we can also do count. And count basically will give you the number of times this value, which in this case is 1, appears in the list. Oh, sorry, list 1. And we'll print this. Yeah, so this appears once. Number 1 appears once in the list because we appended it. And then we can say, we can also remove. So the function for that is list1.remove. We say remove 1. Yeah, so that's removed 1. And then, yeah, so you see 1 is not there anymore. And then we can say, there's also the pop function, which will basically remove that index from the list. So we can say list1.pop. So that removes the index 1. So in this case, that's B. So we can print list 1 and then we get, yeah, so B is not removed. Okay, list comprehension. So we went over for loops and if loops, and basically list comprehension is a way to minimize those for loops or if loops into one line. And so let's say we want a list of numbers from 1 through 10, 10 not included. We can do a list comprehension statement where we can say x for x in range 1 through 10. So this will go through the values in range 1 through 10, and it'll append that to the list. And so our list is 1 through 9. And then we can also do an if statement in list comprehension. So we could say even or odd. So if it's even, then append the string even to the list. If it's odd, then append the string odd to the list. So how we write this is even or odd is our list, and we can say if I2 is equal to 0. So this statement basically is saying if the remainder of I when divided by 2, this is the remainder, the percentage symbol. So if the remainder of I when divided by 2 is equal to 0, that means that the value is even. So we're going to append even, and then else odd for I in range 10. So if we so it should go from even to odd, which keeps switching until it reaches 9 in this case. Okay, so we'll go over functions next. So basically, when we define functions, we have def and then the name of the function. So we'll just call it function 1, and it has no parameters. And we'll just say that this function prints hello world and it doesn't return anything. So when we call this function, we would call it by saying function 1 parentheses, because there's no parameters, and it should print hello world. So another example of a function is something that, let's say we want a function to return a value. So we have function 2. Let's say x is equal to 3 to the power of 2 to the power of 2 plus 24. Let's return x. So because this function returns x, we may want to store that value of that function when we call it. So we can say that the variable var is equal to the function 2. And then if we can print that, yeah. So it returns the value 33 to the function, and that value 33 is stored in var, and it prints the console. Okay, and then last but not least, we don't have to return a variable in any case. We can always return values, or we can even do like a calculations in the return statement. So we can say like def function 3. And let's say we have parameters assigned, which is a. Let's just return a to the power 2 plus 19. And so we can call function, and we can give it a parameter 12. It'll give us a value. Yeah. Okay, so maybe I have to. Okay. There's also some practical uses to this. I know this seems a little like simplistic, but you can have some like practical uses. Like let's say you have like a candy store and you have a number of items and the cost of items. You can define a function, and you can say that the parameters are the number and the cost. You can multiply them in the function and then return that total, so that your function will basically calculate the total cost of that number of like candies, and it'll print it out to the console if you want. So those are other examples of like how you could use functions. And we can also go over lambda functions. So again, lambda is just an easy way for you to do, I guess, calculations without having to write a whole function. So we can say the lambda function is equal to lambda, and let's have xy. And so this lambda function will basically add x plus y and then add 190. So when we call the lambda function, we're going to say, let me make sure I'm spelling this correctly. We're going to give it the parameters 10 and 20. And then so when we run this, it will give us 220. So it's taking in these parameters, which are x and y in this case, and then it's adding 190 to that. Okay. So we're going to go over just really quickly what Pandas is. So you may not have heard of Pandas, but Pandas is basically a Python library that you can use to work with data sets. And Pandas, you can use it to manipulate or store data. It has functions that can help analyze, clean, and do all sorts of things with data. And it's a very easy way to deal with data sets inside of with Python. So we can say when we're using Pandas, we want to import the library. So we're going to say import Pandas or say as PD. And let's say we want to read a CSV file. So this CSV file, just think of it as a data set, which just has a bunch of keys and a bunch of values for each row. So like rows and columns. So we can say tips is equal to pd.read CSV. So this will basically read the file. So let's say we have this file, which I'll just copy and paste. And so this file just basically, or this CSV data set basically just looks at the tips given to a person based on different categories. And so let's say we want the info of that. You can say tips.info, which is you say that it's a function inside of Pandas that will give you information about the data set. So .info, it gives you important details about the data set, like the number of rows and columns, the null values, the type of data in each column, etc. So to print that. Yeah, so we have total 7 columns, 244 entries, and the data types are here, and then yeah, memory usage, all that stuff. And then we also have functions like describe or head. You can do head. So tips.head will basically head. It gives you a quick snapshot of the data, which is like the first 5 rows. But you can also specify more rows by passing it as a parameter in here. So we'll just say head. So this would give us the first 5 rows. Let me delete this. So if we run that, so this is the first 5 rows, and again, it starts from 0, and yeah, so it basically just gives the first 5 rows of the data set. And then last but not least, we have dot shape. So this one basically outputs the dimensions of that data frame, and it's in tuple form. I think we had to specify the number of rows and number of columns. So let's say 3. Okay, I'm not sure why this isn't working, but yeah, basically the dot shape function would output the dimensions of a data frame inside of a tuple. Yeah, so that's all we have for today. Hopefully this was helpful, and thank you guys for listening.
Awesome. So thank you, Sanjana and Aswin, for the implementation and presentation. And as we come to a conclusion here, I want to thank you first of all for showing up. And also I wanted to mention the Student Machine Learning Coalition, or SMLC, which is a youth-led organization that basically aims to make machine learning more accessible and resources more accessible for all people across the nation and world to learn about machine learning. Currently, we have 8 chapters spread across the San Francisco Bay Area, New Jersey, Nepal, and India. And you can check out our website at www.smlc.dev to learn more and even start your own chapter and reach out to us with your own projects and ideas to get involved. And thank you for coming once again.
All right, thanks a lot, Sanjana and Aswin and Joseph. This is the Tech Tree YouTube channel, and we like to have videos like this, working with organizations like the Student Machine Learning Coalition. So check the video description below for information on how to reach out to them, connect with them. If you have any questions, definitely like to help out as much as possible. And again, thank you for teaching this workshop. If you visit the rest of the videos on this channel, you can find more workshops for Python, for data science, also other languages like JavaScript. So everyone take it easy and we'll see you around.